Okay, hi guys, this is page 10. And take a moment to pause the video and write this stuff down that I have boxed in green. So we're going to need to know, especially for the second and third examples, that -1 is less than or equal to sine of theta, which is less than or equal to 1. And then the same with cosine. And you could see it like from our unit circle, that sine and cosine, their values cannot go past -1 and 1. So we're about to use something called the squeeze theorem. And this is just a little picture, and right here I found something that states the squeeze theorem. But I'm just going to do this example, and then I think you'll see how it goes. And okay, so given that 3x is less than or equal to f of x, which is less than or equal to x to the third plus 2, evaluate the limit as x approaches 1 of f of x. Okay, so the squeeze theorem, guys, like the big idea behind it is, or one of the big ideas is this. So if you look at this real quick, if 5 is less than or equal to u, which is less than or equal to 5, what we can conclude is that u is equal to 5. And I'll just let you think about that. And if you want to discuss it further in class, then we absolutely can. But so that's a conclusion we could make from this two-part inequality. Okay, so it goes like this. So first, in order to use the squeeze theorem, you need an inequality like this. So we've got 3x less than or equal to f of x, which is less than or equal to this. Okay, so this is the first condition of the squeeze theorem, is that you need a function that is squeezed between two other functions. And then the second condition, you've got to do the limit as x approaches 1 from, no, sorry, just 1. The limit as x approaches 1 of 3 of x, and then we'll figure out the limit as x approaches 1 of x cubed plus 2. All right, so you do the limits of the functions on the ends, and if they are equal, then we can conclude that this limit would be that same number. So that's how the squeeze theorem works. So for this limit, I could just plug 1 in. I get 3. Okay, if I also get 3 for this part, then I can conclude that the limit of the middle function is also 3. So here I could just plug 1 in, and I get 3 again. Okay, so once you have these 3 things, then we will say, I'm just doing like an if-then arrow, then by the squeeze theorem, the limit as x approaches 1 of f of x is also equal to 3. Okay, so 1, 2, 3. If these two are equal, then you could say, therefore, by the squeeze theorem, and then the limit of the middle one will be the same as those there. Okay, so now let's move on to this one. All right, so the second and third examples, we are going to be using the inequalities that we wrote down at the beginning. Okay, so evaluate the limit as x approaches 0 of this right here. Okay, so what I'm going to do is I'm going to take off to the side, I'm going to take just the sine part. Okay, so what do I know about sine? I know that sine has to always be between -1 and 1. So sine could be greater than or equal to -1 and less than or equal to 1. Okay, now the difference between what I've got in the middle here and what I'm taking the limit of is that I've got this x squared as well. So what I can do is I can multiply all of these parts of the inequality by x squared. X squared times x squared. And you've got to be careful with inequalities, because if you multiply an inequality by a negative number, then the signs would flip. But x squared, if you have something squared, that's always going to be positive. So we are allowed to do this here. Okay, and now I'm going to launch into my 3 conditions and then my conclusion. So 1, I've got negative x squared is less than or equal to x squared sine of 1 over x. Okay, so I got this inequality here by taking this original fact that I wrote down, and then I multiplied all the parts by x squared. And then I get this here. Okay, now the second step, I'm going to do the limit as x approaches 0 of the leftmost function. And then I'm going to do the rightmost. Okay, for this limit, you could just plug 0 in, and you get 0. Same with that one. Okay, so it's got to be the case that the limit as x approaches 0 of this middle function is also 0. Okay, by the squeeze theorem, the limit as x approaches 0 of x squared sine of 1 over x equals 0. Okay, now let's do this one. So use the squeeze theorem to evaluate that. So I'm going to start off with the cosine. Okay, so I've got cosine of x. I know that is less than or equal to 1 and greater than or equal to negative 1. Okay. Now, instead of just a cosine, I want 2 cosine. So I'm going to multiply every part of the inequality by 2, which is positive, and I get negative 2 is less than or equal to 2. Okay, and now I can divide every piece by x, and then in the middle I will have what I've got here. And, you know, I said earlier, like, that if you are multiplying or dividing by a negative, the inequality signs flip. But let's look at what x is doing. X is approaching infinity, positive infinity. So we're only considering this, this function here for very large positive numbers. So that means that I could divide by x like that. All right, so now I'm going to go into my 3 conditions. So here's the first one. Negative 2 over x Okay, and then I do the limit as x approaches infinity, negative 2 over x. Okay, so x is approaching infinity, so I want to think about growth competition. What is outgrowing what? So in this case, the bottom is outgrowing the top. So the bottom is getting enormous, the top is staying the same, so the entire fraction is shrinking. Shrinking, 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 so the limit is 0. And then the same with this one. Okay, so by the squeeze theorem, the limit as x approaches infinity equals 0. Okay, here it is.